Welcome to the sixth of 8 brief discussions on high leverage practices from the book Principles to Action. This is practice number 6, Build Procedural Fluency from Conceptual Understanding. In this session, we will define teaching practice 6 of the Principles to Action, consider the best practices for teachers, and connect practice 6 to the Danielson framework for teaching. The Idaho Mathematics Instructional Framework is a modified version of the 8 high leverage practices from Principles to Action, as you all know now. If you would like to read through each of the high leverage practices, you're welcome to pause the video and do so. Later, we'll discuss the thin blue rectangular box on the right. That will be at a future date. In previous videos, we've been discussing the components of facilitating mathematical discourse. This practice relates and leads to mathematical discourse, but isn't necessarily a component of that. Building procedural fluency from conceptual understanding is the opposite of traditional learning of mathematics. We'll discuss why that is in a moment. But this high leverage practice is directly related to implementing tasks, as teaching conceptual understanding would be very difficult, if not impossible, without tasks that promote conceptual thinking, reasoning, etc. So there's a major misconception in education about what procedural fluency is and what it is not. In the Idaho State Math Standards, procedural fluency has 3 parts. Students can solve problems flexibly, accurately, and efficiently. The misconception is that fluency is having students memorize computations or algorithms or learning tricks, mimicking, which we discussed in previous videos, or that they only know a single method. It is a mere coincidence that all these words start with the letter M. Those are the only words I could really think of, and they all start with M. So what does it mean for a student to do math flexibly, accurately, and efficiently? As a point of clarification, this does not only relate to making calculations. We usually think of procedural fluency as making some simple calculations. This also applies to solving problems. Take, for example, solving a system of 2 linear equations. To demonstrate procedural fluency, students would need to have multiple methods to solve this. Their methods would need to be accurate, and as the students learn methods, they should be able to identify and use methods that are most efficient. This particular problem can be solved by guess and check. Is that efficient? Probably not. That is especially true, guess and check not being efficient, is especially true as problems become more complex, like quadratics, rationals, cubic functions, more. So where guess and check may work right now with 2 simple linear equations, that's not a method that's going to really go the distance for students later on. There's nothing wrong with beginning with guess and check, but there are multiple ways to solve a system or to understand how the system is working, and students should have the opportunity to explore those different ways. The main ways, if I was looking at this and I was teaching it, you could solve this algebraically, graphically, you could use a table, and of course you could guess and check. Even within those strategies, there are more and less efficient strategies. For example, we could solve algebraically using substitution or elimination. When teachers spend significant amounts of time with the concepts and allow the students to grapple with the challenge, they will then develop their own procedural fluency. We can build many of these concepts starting with the very inefficient strategies of guess and check, and then move on to other strategies that would also work. I'm not sure if you're tired of reading these excerpts or not, but it has provided a little bit of consistency for these videos. As you read this slide, you'll see that there are 3 main ideas. Go ahead and pause the video and consider what these 3 ideas are, then press play when you're ready to continue. Hopefully, You picked out that students generate strategies. Then the teacher helps the students make connections. And finally, procedures and representations are scaffolded to provide a student a range of different options on how to think and utilize the concept. If you think about how that's contrary to some of our traditional math, we probably wouldn't introduce notes first, which is normally what we do with math. Here are the notes. Okay, now let's do this. This would be, here's a question. Think about how you can make sense of it, how you might be able to solve it. And then the teacher helps them make some connections with what they're already generating and thinking. I spoke at great length in video 2 about conceptual and procedural understanding. Hopefully you can recall that we need both and that we should start with conceptual understanding. Many math classrooms start with the opposite. They start with procedural processes. Then they try and introduce conceptual understanding, or they omit the conceptual understanding altogether. The realist in me knows that allowing students to start conceptually is very difficult, particularly if the curriculum is set up to start with procedure. Then the teacher now needs to come up with conceptual ideas, tasks, questions, and that would be very, very difficult as a teacher. By no means would I suggest that a teacher can and should change this overnight. As our teachers understand the concept, pun intended, of starting conceptually, they can start finding, exploring, trying strategies in their classroom, and over time develop this methodology. And as they're doing that, I'm a firm believer that teachers are experts. And as you bring a new pedagogy, a new methodology to them, they can then start making sense of it and utilizing it in their classrooms. So how do teachers do this conceptual understanding into procedural fluency? In the book Mathematical Mindsets, Joe Buller quotes Conrad Wolfram, who poses 4 stages to working on mathematics. We've already discussed stage 1 and 2 in previous videos about posing questions and about taking real world and making and creating models. Stages 3 and 4 can complete the connection from conceptual understanding to procedural fluency. In my experience, most classrooms, my own included, spent the majority of the time performing calculations. Step 3. This stage requires the smallest amount of thinking. Often, as the teacher, I would try to do the stages 1, 2, and 4 for my students. That I would pose the question. I would show them how to make a math model for that. And then I would look at my model and show them again how, once I got my answer, how that answered the original question. There's nothing easy about connecting conceptual and procedural understanding and learning. It is quite difficult and requires solid tasks and questions. Most math textbooks simply do not have either. And so it becomes the teacher who needs to develop those tasks and questions. And as I said earlier, I believe teachers can do that once they understand the concept, but there's nothing easy here. So let's go back to our example of solving a system of 2 equations. If I put this question on the board, what might be some questions I could ask, knowing that up to this point, they've only seen single linear equations? You as the administrator very well may not have that answer of what questions you could pose by showing these 2 equations. Your teachers might. A teacher might ask any one of these questions. These are questions I kind of came up with. What do you notice about these 2 equations? Do you think there might be an x value and a y value that would work for both equations? Suppose that there was an x value and a y value that worked for both equations. Work in your teams and try and figure out if there's a way that you could figure out an x value and a y value that works. Do you think there could be more than one solution? to this, more X values or Y values that would work. The teacher might let them struggle and then suggest graphing or making a model. The teacher might put these equations into a real life scenario and ask that scenario, that question, and then let that kind of lead the conversation and the thinking for the students. There's lots of different ways to ask these questions about this to get systems of equations. There's no one right answer. Teachers can decide what's best and what works for their classrooms. I will tell you though, and I would tell teachers, students will struggle, complain, and get frustrated the first time a teacher tries to start with conceptual ideas first. That's because they're not used to thinking. They're used to the mimic model, which we've talked about, of being shown what to do and then regurgitate. Training students to do some brainstorming, some math brainstorming, will take some conditioning and take some time. You can let your teachers know it will be messy and it will be hard, very hard, the first time they do this. They would need to stick with it until they can work out all the kinks. And that would take a large commitment from your teachers. As I just mentioned, I wouldn't expect this to be overnight. Developing this kind of math classroom is a process. This is the diagram from NCSM's book, Instructional Leadership in Mathematics Education. This shows the progress of where a teacher might be and where they could make growth. You may pause the video if you'd like to read through this progression and then press play when you're ready to continue. I don't want to rehash what we've been discussing so far, and I think you get the general idea. This progression will be modified to fit our instructional walkthroughs, and so as you're welcome to pause this, read it, but we will be discussing this more and practicing this as we go through our walkthroughs. When we connect this to Charlotte Danielson, I would suggest that there's two areas that this practice correlates to the framework, at least two. Domain 1A, applying knowledge of content and pedagogy, emphasis on pedagogy, that a teacher knows how to start with conceptual and then lead to procedural fluency. That would be a pedagogical piece. The second would be using questions and discussion techniques, and I'll explain that in just a second. There are other components that this would fit and lead right into, but we're not going to discuss that right now. In component 3B, there is a critical attribute that says this: the teacher builds on and uses student responses in order to deepen student understanding. I've seen that whole group before. I've seen a little bit of that in small group. I regularly challenge my teachers to do this. That is, I want them to allow the students to think, allow them to respond, whether that's whole group or small group or pairs, however they're responding, and then the teacher can then know, and then they can structure and sequence those responses so that they can deepen the understanding of other students. And that's the connections, and that's how we help these students make those conceptual connections by using what those students responded to when you asked questions. I always feel like these go so fast. This concludes our discussion on practice 6, building procedural fluency from conceptual understanding, from the Idaho Mathematics Framework. I just want to reiterate one thing about what fluency is. It's that they can think flexibly, they can think, their methods and strategies are accurate, and that they're efficient. Flexible, accurate, and efficient. That's what we look for in fluency, not necessarily memorization, that they know the algorithm, etc. But I said this concludes it. Now it's done. This concludes it for our discussion about high leverage practice 6. As a reminder, this is the process that we're going through this year with accelerated learning. I've made a couple adjustments, as you've probably seen in the last video. I didn't make any adjustments from that video. February, it'll all be asynchronous, and then we'll meet together again in March. Again, if you have any questions, thoughts, comments about anything that we've been discussing, please reach out to me. If you have any, unique circumstances that you want some thoughts or ideas or just a sounding board, please reach out. Thank you.